Why does time tick slower for someone moving fast? Why does a fast-moving object literally shrink in length? And why can a tiny bit of matter turn into an enormous amount of energy? Welcome to Special Relativity, the moment physics stops behaving like common sense. Imagine you're in a completely dark train moving smoothly. You toss a ball straight up, and it lands back in your hand exactly as if you were standing still. Inside the train, everything feels normal. But to someone watching from outside, the ball travels in a diagonal path. Two observers, two different realities, both correct. This is the learning studio, making mind-bending physics feel simple. Einstein realized something radical. The speed of light is the same for everyone, no matter how fast they're moving. And because that speed can't change, everything else must bend to make it work. Time, distance, mass, even reality itself. Let's start with one of the wildest results: time dilation. If you move very fast, time slows down for you compared to someone who stays still. Not metaphorically, literally. Atomic clocks on fast-moving jets tick slower. Astronauts age slightly less than people on Earth. Time is not universal. It depends on your motion. Now, if time stretches, then we naturally move into something equally strange: length contraction. To a stationary observer, a fast-moving object appears squished in the direction of motion. Move faster, contract more. At everyday speeds, it's invisible, but at speeds close to light, it becomes dramatic. Your 10-meter rocket might look 5 meters long to someone watching from Earth. Motion affects time and distance the same way squeezing a balloon changes its shape. One dimension changes, others respond. But relativity doesn't stop at space and time. It reaches into the core of matter itself, giving us the most famous equation ever written: E equals mc squared. This tiny formula says mass and energy are the same thing, just in different forms. A small amount of mass contains an enormous amount of energy because c fluid is huge. This is why nuclear reactions release so much energy. A tiny bit of mass turns into pure energy. This single idea explains why the sun shines, why nuclear plants work, why fusion powers the stars, and why particle accelerators create new particles by smashing old ones. Relativity is not science fiction. It's built into GPS satellites, particle physics, nuclear energy, and the behavior of fast-moving cosmic objects. And here's the curiosity to carry forward. If motion can bend time and space, what happens when gravity joins the picture and warps space-time itself? That leads straight into general relativity, where the universe becomes a curved, dynamic fabric.